One of the things that I've noticed over time as I worked with high availability, fault-tolerant systems where the network is built in such a way that if a single component fails, it can continue to work, is that it often requires spending twice as much money on hardware and licenses. What do you mean? Well, let's say we have firewalls. We want redundant firewalls. Well, you could have 2 of them, and that costs money. If you want redundant routing, you got to buy 2 of them, and that costs money. So in the case of providing fault tolerance for a default gateway for customers to use, if we're using the simple implementation of HSRP, Hot Standby Router Protocol, or VRRP, the Virtual Router Redundancy Protocol, in most cases, we have one router that's doing all the work, forwarding all the traffic, and the other one is just sitting there. I'll watch you, and if you die, I'll take over. Well, wouldn't it make sense or wouldn't it be great if we could somehow load balance the traffic over both devices? So maybe they're both working at 30 or 40%. And then if one dies, then the other one could take over until we recover and fix the network. That's ideal. And that concept can be done with a first hop redundancy protocol called Gateway Load Balancing Protocol. Let me show you how it works. So let's leverage this same logical topology again, but this time with Gateway Load Balancing Protocol. As a reminder, we've got R1 at the top. We've got R2 here on the bottom. They have their gig 1/0 and 2/0 interfaces respectively connected to the 10.16.0 network. R1 has the last octet of .1, R2 has the last octet of .2, and Bob's PC is at .10. And let's imagine there's other customers out here as well. So we have like other devices that are all connected, and they've got their respective host addresses on that network. If we want to provide fault tolerance for all these devices and their default gateway, we would create a virtual IP address once again. So in the previous 2 videos, one on HSRP and one on VRRP, we use the IP address of .3. So just as before, with HSRP and VRRP, we would configure all these devices to use a default gateway of .3. So 10.16.0.3 would be their default gateway, and then we'd have that IP address supported by Gateway Load Balancing Protocol. And just like when we configured VRRP, and just like when we configured HSRP, the configuration for Gateway Load Balancing Protocol is done on these respective interfaces on R1 and R2. And here's the syntax. It is, you go into interface configuration mode, and the command is GLBP space, a group number, and I'll put 10 as an example, space, the keyword IP, space, and then the virtual IP address we're supporting, 10.16.0.3. As we look at that command, does that look similar to something else that we've configured in the previous 2 videos? And you may be saying, whoa, wait a sec, this looks like the exact same syntax except for the word. Like for HSRP, the command is standby, followed by all that being the same. And for VRRP, the command is VRRP, with all the rest being the same. So the implementation on these interfaces is super easy to do for all of these first hop redundancy protocols. Also, to see their status and how they're doing, you just do a show for each of them. Show VRRP, show standby, show GLBP. Now, the benefit of using GLBP on these routers for fault tolerance of that default gateway address is that we can actually load balance. You see, if we go back to VRRP and hot standby, their primary method of supporting that virtual IP address is to send all the traffic through one of the routers, and then the other router just sits there waiting for the primary to fail. So in VRRP, it was the master. In hot standby router protocol, it was the active. However, with GLBP, it does load balancing by default. And the question might come up, well, how does it do that? Well, let's imagine that Bob is sitting here, he turns his PC on, he needs to figure out the layer 2 address for his default gateway, so he sends out an ARP request. Great. So in that ARP request, it says it's a broadcast. Hey, I'm looking for whoever owns the IP address of 10.16.0.3. I need your layer 2 address. And with Gateway Load Balancing Protocol, one of our routers is going to be acting as the active virtual gateway, and it responds. So the active virtual gateway responds to that ARP request, but what it does, it's going to respond in a round-robin fashion based on the virtual MAC addresses that are being used by this GLBP group. So if we were looking at the responses, let's say Bob comes in, does an ARP for the default gateway, and the AVG responds with MAC address number 1. And then let's say Lois, sitting at this PC right here, she does an ARP request for 10.16.0.3. The AVG responds with MAC address number 2. And we have more than just 2 routers in this group. But the key is that the AVG is round-robining the responses so that there can be an even load or a more even load of traffic going through all the routers. And in the background, if one of the routers fails, the other router or routers will pick up that slack and continue to forward traffic on behalf of the other router that is no longer part of the group or the router that failed. So once again, it's transparent to the user. Now, behind the scenes, there's lots of bells and whistles and tweaks that we can set up to control the proportions of how much traffic do you get and how much traffic do you get. But we'll save that for another skill. In this video, I want to share with you how to configure Gateway Load Balancing Protocol, how to verify it works, and that's what we're going to do right now in the lab. So here in the lab, we're going to launch the DC NUG administration machine and open up PuTTY. And we'll click on the Servers tab on the far left, and we're going to open up connections to R1 and also to R2. Great. And let's start our configuration here on R1. So on R1, the first thing it's a great idea to get in the habit of is to verify what the interfaces are that we're going to be configuring. And the best way to do that is show IP interface brief, which will show us the interfaces, their status, and also the associated IP address on them. So the interface that we're after is this bad boy right here, which is gig 1/0 here on R1. So we'll type in config T, go into configuration mode, and interface gig 1/0, and we'll issue the GLBP command, GLBP space. Then we'll go ahead and put in the group number, pick the group of your choice, space. We'll then use the keyword IP, space, question mark, and then we'll put in the virtual IP address, which is 10.16.0. And looking at our notes, we are going to use .3 as that virtual IP address that our clients are going to use. So we'll put in 3 there, and we'll type in end, and in a few moments we'll get a console message indicating the status of this GLBP speaker. So let's go over to R2 and do the same configuration. So here on router 2, we'll do a show IP interface brief just to verify our interface. So here it's going to be gig 2/0. We'll go into configuration mode, interface gig 2/0, and GLBP space, the group space, keyword IP space, and the virtual IP address of 10.16.0.3, and boom. And then in a few moments, these two routers are going to be participating and supporting that virtual IP address. And they're also by default going to do it in a round robin fashion. So the first client who ARPs for the .3 address will get one layer 2 address. And the second person who ARPs for that address is going to get a second layer 2 address. So the show command that will give us the details on how Gateway Load Balancing Protocol is set up is show GLBP, and press enter. And we'll hit space. And for here we have 2 forwarders, 2 routers that are willing to forward traffic on behalf of users. One is supporting the layer 2 address of this, ending in 0A01, and the other router is supporting the virtual MAC address of this, ending in 0A02. So 01 and 02. So if we went to a client on that network, the 10.16.0 network, and we looked at their Arp Cache and said, hey, what do you think the layer 2 address is for 10.16.0.3? Some of the devices would have the first MAC address, other devices would have the second MAC address. So let's go verify that by going to our client in the lab environment. So here on our client, we'll go ahead and log in. And on the client, let's go ahead and modify the details for the network interface. On this Windows 10 machine, if we right-click on the Windows icon, bottom left-hand corner, and from the menu, we can click on Network Connections. That's a fast way of getting there. And then we can right-click here on Network 1016, and then from the drop-down, select Properties. Fantabulous. And then we can double-click here on Internet Protocol version 4, and that way we can change the default gateway from .1 over to .3. Now, in a larger environment, of course, instead of doing static addressing, we could just use DHCP and dynamically hand out the default gateway of our choice. So with .3 selected here, we'll click on OK, click on OK again, and then, this is important, as we do this lab together, we're going to play with the Arp Cache a little bit, and we're going to need some elevated privileges for that. So let's open up a command prompt, but we're going to do it as admin. So we're going to right-click on this Windows icon in the bottom left-hand corner, and from the menu, we'll go ahead and click on Command Prompt, and then in parentheses where it says Admin. Now, as Windows 10 rolls forward, Windows is changing more to PowerShell and other things, but an elevated command shell is an elevated command shell. Let's just do more things at the command line. So here we'll click Command Prompt Admin. User account control saying, you sure you want to do this? I'm going to say yes. I encourage you to do this as well in the lab. And now let's take a look at the Arp Cache on this computer. Now, on this Windows computer, we do an ARP space -A to take a look at the Arp Cache. And right now, this client PC has learned that the IP address of 10.16.0.3 is reachable via the layer 2 address ending in 01. Fantastic. So in the background, at some point, this Windows client needed to resolve what the layer 2 address was, did an ARP request, and got that response. Fantastic. So it ends in 01, and if we ping something on the far side, over on the right-hand side of our network, 192.168.1. Let's go for 11. Okay, great. So that IP address, let's use that for a test. That is something over on the right-hand side of R1 and R2. So this client used the default gateway to get there. Now let's have some fun. Let's go ahead and do an ARP space -D, which means I want to delete the ARP cache, asterisk, and then use the up arrow key a few times. And let's do an ARP-A. Now, depending on how long we wait, it's going to repopulate with some new things. There we go. There is 1016.0.3, and there's that MAC address. Let's go ahead and delete it again with an ARP-D with an asterisk. And let's go ahead and do another ping, which will force an ARP so it can realize what that layer 2 address is once again the default gateway. Hit the up arrow key a couple times, ARP space -A, and check this out. Oh, this is so fun. So the layer 2 address that was handed back to it when it did an ARP request this time is the second MAC address. So if we have 2 or 3 or 4 routers in the GLBP group, the active virtual gateway is actively round robining as it hands out responses. And we could play this game several times. In fact, if we delete the ARP cache, I'm just going to cycle through my commands, do ARP space -D space asterisk, and then we do another ping, and then we go ahead and look at the ARP cache again with an ARP space -A. It was ending in 2, and now it's ending in 1. So the great news about using gateway load balancing protocol is that we have some fault tolerance, the .3 address, we have multiple routers supporting it, and while all those routers are up, they all have an opportunity to do some forwarding of traffic. So we don't have a situation where one router is doing all the work and the other one is just sitting there saying, you're busy. And if you're not busy, I'll take over. So with gateway load balancing protocol, the key here is it gets to do load balancing across those routers as well. So I'm glad you joined me for this lab and this video, and I'll see you in the next one. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.